Thanks everyone for joining this session this afternoon, where we're going to talk about beyond 10 dbt projects and more, leveraging automation and avoiding chaos. My name is Benoit Perigaud. As you might already tell from my accent, I'm French. I live in Madrid in Spain, and I've been working for dbt Labs since January last year, so nearly about 2 years. I'm part of the professional services team at dbt Labs, which means that I work with some of dbt Labs' clients in helping them use dbt the best way possible, work well in the architecture, and so on. And today, we'll talk about scaling dbt. So, quick overview of the agenda for today. First, we'll just do a really quick recap of what it means to set up your first dbt project. Then we'll look at how we can try scaling dbt in a few different ways. At first, we might not be successful, but we'll see a few different approaches that we can have. Finally, or not before the demonstration, sorry, we'll talk about how we can look at how software developers scale their application. We like to do that in the dbt world. We like to take the good ideas that the software engineers have been using for years, so we'll do that as well. And finally, we'll look at the demonstration and putting everything in practice, how we can actually scale our dbt deployments and how we can get our life so much easier using automation. OK, so let's start with the dbt adoption journey, and let's just recap of what it means to deploy a dbt project today. I guess the vast majority of you is already using dbt. The vast majority of you has already maybe set up dbt. And when we set up dbt, dbt doesn't work in isolation. So we need a Git repository to put our code. We need a way to run our code. So if you use dbt cloud, you would set up a dbt cloud project and then a development environment. If you use dbt core, you might be using Docker, or you might use the CLI yourself, but you have to set it up. Then we also need to set up some deployment and orchestration for our dbt job. So developing dbt models is one thing, but we also want to run those jobs on a periodic basis. Again, with dbt cloud, you would create a deployment environment, and you would set up your jobs there. If you use dbt core, you might be using Airflow or another orchestrator or GitHub Actions, whatever. But you also need to have these jobs running. And finally, dbt is nothing without the data warehouse. So when we set up a dbt project, we need to make sure that the data warehouse is set up properly with roles, schemas, databases, and so on. So we can actually do our transformation there. So that's the simple thing that we need to do to set up one project. That's easy. But now, while historically we at dbt Labs we've pushed people to try to stay on one project quite often because it's easier for dbt to manage the whole DAG that way. There is also now people who have more and more models. So we need to scale. The first approach to scaling, which I call like the 0.1, is like the silo approach. So let's say that now you want to break your historical monolith into different projects you want to leverage the dbt mesh. Or after a successful use case, you want to start, like you have more teams who want to start using dbt. Well, the basic silo approach is that each team is going to start again from setting up Git, setting up a way to run dbt, setting up a way to run your job, setting up the warehouse. And yeah, every team just starts from scratch, and everybody do the same thing. So the problem with that is quite apparent, I think. So everybody will be doing things potentially differently. Like nobody will follow the same best practices. So from on the Git side of things, for example, so we won't be using like the same PR templates in the org. On the dbt side, we might not be using the same packages. So it's really just a mixed bag of ways of working. On the deployment side, like some teams might be quite familiar with how dbt works, and then they know that how to set up Slim CI and CI/CD. Some teams might not be able to do that. So this can really easily become a big mess, even if we don't talk about the data warehouse, where maybe each team is going to name databases differently. They would have different naming conventions for their roles, their access. Like it can really be a big mess. And that's what you get. So at that time, like I don't want to be part of the team managing like the data platform. Like you won't know. You might be able to scale maybe 3, 4, 5 projects, but after that, there is no way you will understand what's going on in your organization. So you don't want that. So let's start again. OK, so this time, we'll talk about scaling like 1.0. So scaling, like taking the principle of like dbt as a platform. So for like a successful adoption of like new ways of working or for like transformation in the company, we usually look at things from like 3 different angles. We have like the people side of things, the process side of things, and the technology side of things. So let's just first focus quickly on the people and process. So from the people standpoint, one thing that I've seen well with customers I've been working with is to have a platform team or a central team, which is supporting like internal customers, let's say, which are the data teams. So that's a way you can separate the organization, having this like platform team, central team, supporting like some disparate data teams. And then on the process side, the platform team, they are the ones defining guidelines on what's the best way to use dbt. They are fostering some conversation between the different data teams. They are really helping like a good adoption of dbt. And one of the key things also they do is they provide configured dbt projects to the different data teams. So the platform team is really there to create those projects. The data team asks for one project, they create it, and they give it to them already configured with all the best practices. And then the data teams, what they do as part of this process is they request the project to the platform team. And in exchange, what they have to do is they have to follow the guidelines, they have to follow the best practices that the platform team has put in place. And then this can still go wrong. So what might happen if you don't focus on the technology part of like this people, process, and technology, you have this central team, this platform team. But if you don't invest on the technology side, on the automation side, what you can have is like what's called like ClickOps and WikiOps. So you have like these guides about, oh, you have to click here in GitHub, and then it's going to create a repo, and then you have to click here. So we can put like a branch protection, and then you jump to the warehouse, you click here, you click there. Like you spend your time updating guides because the UI of all the tools we love, they change all the time. You spend your time not really doing high value added work, but the work you do is really just like clicking in different tools. It's updating like, like processes all the time. So this won't work. Another option is like you can also spend effort in like deploying some in-house automation tool. You can, most of those tools that are part of the modern data stack, they have some APIs. So you can have a team which is calling these APIs for GitHub, for Snowflake, Databricks, BigQuery. So it creates everything that needs to be created, and then like have this central team managing this software. It's a good idea, but it is also very complex to do. So you need to maintain this software. You need to, every time like some API change, you need to be aware that, okay, so I need to update my, the way I'm calling this API because this has been changed by whatever vendor. So this can be possible, but it will take a lot of time to get something that works pretty well. So in the end, not a big chaos, but I still think that while you'll be able to achieve like, I don't know, maybe 15, 20 projects, like very quickly, like the platform team is going to be just like they will have like a queue of projects to create, and they won't, the data teams won't be happy because they will have to wait several days to get their project created. It's not a great experience for the whole data community in the company. So let's try again, and this time let's use the cheat code that we do in the dbt world, which is like what do software engineers do? So we did that to create dbt originally, but we can also do that today to know how we want to scale our dbt project. So tip number 1 is software engineers, they use infrastructure as code, or IAC tools. So those tools, they are a way to define the configuration you want in your cloud application without having to interact directly with the application. So it's an alternative to clicking on the UI and so on, and just like writing down what config you want to see in your target, let's say, application, and having some tools doing it for you. So some examples of IAC tools are, some of them are vendor specific. So we have CloudFormation or Azure Resource Manager. These ones are like specific for respectively AWS and Azure. But there are also some generic tools that allow to take this approach of infrastructure as code. The two main or the most famous ones being Terraform and Pulumi. And after this quick intro, I'm going to talk a bit more about Terraform, which in my mind is the most popular generic infrastructure as code tool that we have today. So Terraform is a tool that has been created by a company called HashiCorp. And the way they define Terraform is that Terraform is an infrastructure automation tool to provision and manage resources in any cloud or data center. It means a bit nothing. It means a bit everything. It's a bit fluffy. But what it means is that, as I mentioned, with IAC tools like Terraform, you would be defining the configuration that you want to see in the cloud application into a file locally. So I would say I want a virtual machine in AWS. I want like a firewall. So you define this in a text file. And then Terraform is the tool that will translate this and do all the API calls required in the application. So it will create all those objects for you. If you modify your config, it will check, oh, do I need to modify my config in AWS, in GCP? It will do all of that for you. So we declare our configuration in some files, text files, and then Terraform translates that into calls to the API. But then, like, why do we talk about Terraform for our like modern data stack for DBT? Like, what is the point here? Well, there is a point. If not, I wouldn't be talking today. So the point is that while originally Terraform was really thought for, as I said, like creating virtual machines in the cloud, creating firewall rules, and so on, what Terraform has done is they provided the ability for companies and for the community to create what's called providers. So a provider is a way for a company to integrate their tool with Terraform. Any tool that has some APIs can be integrated with Terraform. And for us in our day-to-day as data practitioners, what's important is that Terraform works with most of the main Git providers. Terraform works with most of the main data warehouses, which means that we can automate a lot of it with Terraform. We don't have to click in those tools. We can just define the configuration we want, and it will automatically be managed by Terraform. Fivetran also has a provider. So there is a way to manage your Fivetran configuration via Terraform. Then you can order pizzas with Terraform. Somebody created a provider for Domino's Pizza. You can write a text file and do a Terraform apply, and you will get a pizza delivered to you a bit later. Anything with an API can be used with Terraform. And dbt Cloud has an API. So that's why also I'm here today. We are going to talk about the dbt Cloud Terraform provider. So I think this is a great story also because a community member, Gary James, created the dbt Cloud Terraform provider a bit more than a year ago, I think. He maintained it for some time. And after some time, we saw that more and more companies actually wanted to use it. And we had a chat with Gary a few months ago. And we asked him if he was OK to hand over the repo to us, so which he did. So now dbt Labs is the official maintainers of the dbt Cloud provider. And we really, really appreciate the work that Gary has done on this one. Now that we understand why Terraform might be useful in our day-to-day, I want to draw a bit of an analogy between Terraform, for people who are not too familiar with it, an analogy between Terraform and dbt, because I think there are some big similarities. And we're going to talk about the declarativeness and the DAG-driven part of Terraform and dbt. So in dbt, we don't write DDL. We write select statements, and it creates the table for us. This is really declarative. Well, in Terraform, it's the same. We don't say, call this API to create my dbt Cloud project. We say, I want a dbt, here at the top right, so I want a dbt Cloud project, and the name is going to be my project. We really declaratively say what we want, and Terraform will automatically configure the application for us. On the other hand, in dbt, we don't have to worry too much about which models to run first or last. We just use ref. We use ref in dbt. That's the full power of dbt when automatically the models are going to run in the correct order. Automatically our tests are going to run. And in the similar way in Terraform, we don't use ref in that case, but we can reference other resources in our code. So here what I'm saying on the top right, like so the second piece of code is that my dbt Cloud environment is dependent on my dbt Cloud project, which means that Terraform is going to build a DAG, and Terraform knows that it first needs to create the project and then the environment. When I was talking before about building your own automation as part of a platform team, like this is really something that's not easy to do normally. With Terraform, it comes out of the box. So this is really a great tool for like taking the complexity away from like how we configure cloud applications. So after talking about Terraform for a bit, let's talk also about other tools. Terraform itself is not going to make our life easier, maybe just a bit, but we need also other tools. What is available in the tool belt, let's say, of software engineers is templates and CI/CD. So on the templating side, there are some tools and libraries that exist to allow people to create templates of how a good practice project looks like and derive it, like just changing the name, for example, and making it possible to create many, many of them. So for those examples, we have Cookie Cutter and Cruft. Those are tools that allow us, for example, to create like the template of what is a good DBT project. So with the good naming convention for our folders and so on, our DBT packages, like we have a list of like predefined DBT packages that we want every team to use in our company. We can do that with Cookie Cutter. On the Terraform side, we can also define templates with what's called Terraform modules. So it's a way to hide some complexity of Terraform and just allow people to, by defining a few values, let's say their DBT Cloud project name, being able to like generate everything for them. And I'll show you that in the demonstration in just a bit. And then another tool that we have in our tool belt is CI/CD. We already use CI/CD today in DBT. We already do CI/CD to go between our feature branch and main. We push our code in a Git repo, we get it merged, they give some automatic testing. Software developers use that all the time. We already stole that from them a few years ago, and now we can steal it again for when we talk about how we can scale our projects. So now that we talked about first Terraform, templates, and now like CI/CD, let's put it all together and let's jump actually directly into the demonstration side of things. So what I'm going to show you now is going to be a short video. I'll do the voiceover of the example of a project. Let's say that I will play the role of a platform team member. I created a repo called DBT Avoid Chaos. In this repo, I allow people to write some files. If they want a new DBT project, they just have to add a file in this repo, and automatically we are going to trigger some CI/CD. Automatically we're going to retrieve some information from our template, and at the end of the process, people will get a GitHub repo created. They will get some Snowflake database, roles, warehouses created. They will get a DBT Cloud project created, all of that automatically. So the way it works is that this DBT Avoid Chaos repo has some GitHub action in there. So what we can do is whenever we do a pull request in this repo, we are going to, when we do the pull request, do a Terraform plan. Terraform plan is the dry run of Terraform. So we are going to be able to see what are all the different objects that I'm going to create if I approve this PR. And then on PR approval, what we do is a Terraform apply. So this time it's not a dry run anymore. This time we're going to create all the different objects, and Terraform will manage all of that to us. As we discussed, Terraform will know which order we need to run those things, all of that automated. So let's jump into the demo and see how it works. So here I am, is it playing? Do I need to go next? Yes, okay. So here I am in DBT Cloud. Right now I have 4 projects, like finance, procurement, product, and sales. Okay, so 4 projects, and today the HR team comes and like, I want my project. Okay. So the HR team can jump into this repo, or the platform team can do it themselves and create a new folder. So here we're going to create a 5th folder, which is just a copy of number 4. We create project 5. The only thing we have to do here is to go to terraform.tfvars, and we can change some values. So we can put our Snowflake account, our DBT account information, the template we want to use. Here we can define like which size of warehouses we want in Snowflake. But for us, what we want to do is we want to change the name of the project. So this time, HR. We save that. This is like basic, I would say, like Git workflow here. We create a PR. So first, sorry, we need to like push our branch to Git. And that's the only thing required to create a new project. So it can be self-served by the HR team. It can be done by the project team, the platform team. Like that's completely up to the company. So I'm just going to like publish the branch now and jump into DBT Avoid Chaos. We're going to create a pull request here. So it's very similar, I guess. Many of you would be creating pull requests on a daily basis if you use DBT. And now that I created the pull request, I have some automation that's going to kick in. So that's the Terraform plan that I mentioned. GitHub is running. And what I'm checking now is further changes just checks if there are changes under my deployments folder. So you might have seen that in the repo before. All my projects were under deployments. So here I'm checking, did anything change under deployments? So this is like the first part of my workflow. And in a few seconds, we're going to see, yes, it changed. So it worked. There is like project 5 that was created. And now we have Terraform plan, which is, as I mentioned, the dry run. We are not going to change any configuration in GitHub, in Snowflake, or in dbt Cloud. We are just asking Terraform, what would you do if I were to apply, or if I wanted to like push this configuration to the cloud? So we have a few different steps here. And what's going to happen at the end of this step is that we will be able to jump quickly into our pull request again. And this code that I created is that it added a comment to our pull request. And now here we can see the plan. So the plan is, again, like the dry run, like seeing what's going to happen. And here, if we look at the details, we can see that we're going to create like some databases in Snowflake. So their names depend on the name of the project that I created. So this one, dbttf, HR dev, and prod. We're going to create some repositories. I think it's going to come in a second. We're going to create a GitHub repo, which has a specific name, which is going to use a template that I created. And what we'll see just in a second is that there is even like I can put already some branch protection on main, and I don't have to do it by hand later. So this will all be done automatically. And then I'm creating, of course, a dbt Cloud project here called tfhr. So quite a few different steps in here that are going to happen automatically. And here I'm also creating some jobs following our best practices. So here I have a CI job that I'm going to create, as well as a daily prod job, which is just a dbt build. OK, so as a platform team now, I'm OK with this config. I'm going to approve this request. And when I approve it, we then do the Terraform apply that I mentioned. So this is no longer a dry run. Now if we go to action, we're going to, again, trigger some activities. So again, we check, are we changing some things under folders? So yes, we changed things under folders. We changed like the deployment project 5. We have this second action kicking off. And this time, again, we are going to do the configuration in the different platforms. So this takes just a few seconds. And the main difference here is that instead of doing a Terraform plan, we're going to do a Terraform apply. So we let it initialize for a few seconds. And when this is done, we'll be able to see that everything that we said was going to be created is actually going to be created, which means that we'll be able to see it applied actually in our different tools. So this is all green. It all worked fine. Yes. And now that it's been finished, like if we jump back into dbt Cloud, oh, tfhr, it's there. So I created a new project. If I look at the repository, there is a new repo that has been created, like dbt tfhr, so following a naming convention that I decided. And if we look at it, we'll be able to see that it's been created by Terraform automatically for me, like just now. So I have my new project following my best practices. Here, of course, I have my name, which is the tfhr. So this is the templating side of things. I have dependencies.yaml where I have my different packages. Everything is fine. And then under models, I'm following the naming convention of my company, where we have Mart, staging, and in this staging, we have our different sources folders and so on. So Git, all set, dbt Cloud, all set. If we look at the connection side of things, so I've created a database in Snowflake, a warehouse in Snowflake. It's already configured, all good. And if I just now select this project and go to deploy, environments, I created 3 different environments in dbt Cloud. Automatically via Terraform, I have my prod, which has a dbt build. So every day is going to run all my models. I have CI/CD already set up in dbt Cloud. So whenever someone does a a PR to main in this repo, it's going to trigger automatically this CI check. So I have everything already set up. And now, instead of having these 4 projects I had at the beginning, I have 5 projects. 5 minutes. That's really, I think, counting the time. That's the time it took between the HR team wanted a project and the moment they are able to query it and start building their first models. Like without automation, we might be talking about, oh yeah, like the time is like a week from now. A week from now, you might be able to get your project, or maybe like next sprint. Now we can do all of that in 5 minutes. We've created the repo, we've created the dbt Cloud project, We've done the changes in the data warehouse, everything in just 5 minutes. And that's where we can see that this automation can really scale. 5 minutes for one project. I'm pretty sure that if I was to create 20 or 30 projects, it would take me maybe 30 minutes. Like, that's how easy it is to scale. The platform team doesn't have to worry anymore about setting up projects for their users. They can really focus more on the value-added things. They can help them with their DBT issues. They can think about new ways of working. They can think about new guidelines that they want to provide to their teams rather than spending time doing this setup. So what's next? Like, this is just scratching the surface. All of the code that I've shown is open source. It's all available online. I think maybe the DBT Avoid Chaos is not open source yet. I just need to connect to GitHub. But yeah, it's all available for anyone. Like, someone could just tomorrow clone, or even today. Why wait tomorrow? Today could clone the repo. Just put your Snowflake account name, your DBT Cloud account name, and you could get projects in 5 minutes. And the way it's been built is that today I've built some templates in Terraform, so what's called the Terraform modules, that work with DBT Cloud, Snowflake, and GitHub. But this is really, really easy to build it in a way that you can also have the same configuration for BigQuery, for Databricks, for GitLab. I don't know if I will be the one doing that. I would love if some people participate in those repos and start building modules for those. But then it is very easy to, like, component by component, being able to, like, reuse this solution without having to, like, do too much work by yourself. If you have any question about anything that I wrote here, you can look at any of those repos, raise some issues. If you're interested in the DBT Cloud Terraform provider, you can check it on the HashiCorp registry. And if you have any question about any of that, I'm available after this session and also as Benoit DBT Labs on Slack. Thank you.